Namaste, welcome to Knowledge Plaza YouTube channel. It's all about mathematics. Today, as I'm before you to discuss about NCERT 9th standard topic, that is polynomials. Okay, so you have already studied about algebraic expression and their addition, subtraction, multiplication, division in your previous classes. Okay, and also you have learned the factorization. Okay, factorization of algebraic expression, and also you have studied some of the identities called a plus b whole square. A plus b whole square is equal to a square plus b square plus 2ab. A minus b whole square, a square plus b square minus 2ab, and one more, a square minus b square can be written as a plus b into a minus b. So these are the identities which you have studied in your 8th standard and previous classes. Okay, and also you have used these identities while factorizing the algebraic expressions. While factorizing the algebraic expressions, you have used these identities. Okay, and now we are going to discuss and we are going to study about the one of the type of algebraic expression, one of the particular type of algebraic expression, that is polynomials. Okay, in this chapter you are going to study about remainder theorem, factor theorem, and their uses while doing the factorization of an algebraic expressions or polynomials. Okay, and also you are going to learn about some of the identities of and their uses while factorizing and while evaluating the values of the algebraic expressions or polynomials. Okay, these are the contents you are going to study in this lesson, polynomial. Okay, so regarding this chapter you are going to know about some of the pre-knowledge regarding the polynomial. Okay, so let me discuss some of the pre-knowledge which is essential to know. Okay, so far you have already studied about algebraic expressions, type of algebraic expressions, terms and their types, coefficients and the types of coefficients, and then operations on algebraic expressions, right? And now we have quick revision or quick review about them. Okay, algebraic expressions. Algebraic expressions, these are the mathematical statements in which the terms are connected by positive and negative or additive and multiplicative signs. Okay, the statements in which the terms are connected by additive and multiplicative signs. Okay, and the terms are called constants, variables, are both the combinations of constant and variables. Okay, terms are the constant or variables or combinations of constant and variables. Okay, and there are two types of terms. There are two types of terms which are like terms and unlike terms. Yes, so like terms means the terms which are having same variable and the same exponents. Terms having same variable with the same exponents, like 2ab, b, 3ab, like this. Okay, so these are the like terms. When we say that terms are like, if they have the same variable and same exponent. Okay, and next, unlike terms. Unlike terms, the terms which are having same variable with different exponents. Same variable with different exponents. Same variables but different exponents. So these are not the like terms. And one more definition, therefore, unlike terms, that is same variable with a different exponents and different variables and same exponents. Okay, so these are the types of terms which are like terms and unlike terms. And next we are going to know about types of algebraic expressions. To know about the types of algebraic expression, before that, one thing, that is coefficient. Coefficients. Coefficients means the companion part of the term. The companion part of the terms are known as coefficients. Means 2ab is a term. Okay, in this the coefficient of a, the coefficient of a is 2b. The coefficient of a means 2b. Why? 2 and b are the companion part of the term. So that's why 2b is the coefficient of a. If suppose the coefficient of b is, that is 2a. Coefficient of 2 is, it is ab. Okay, these are the coefficients. Coefficient means the companion part of the term. The companion part of the term is known as coefficient. And next, all types of algebraic expressions. Types of algebraic expressions you have already studied in 8th standard, right? Monomial, binomial, trinomial, and then polynomial. Monomial. Monomial means an algebraic expression having only one term. An algebraic expression having only one term. It may be a constant, or it may be a variable, or it may be a combination of both constant and variable. So it is also a term, it is also a term, and it is also a term. Those are the single terms. Okay. So an algebraic expression having only one term, then we say that it is monomial. Next, binomial. What are binomials? Binomial means an algebraic expression having two terms. An algebraic expression having two terms. Let us see. X plus 2, x square plus x, x plus y. So these are the binomial. An algebraic expression having only two terms. Okay. And next, trinomial. Trinomial means an algebraic expression having three terms. An algebraic expression having three terms. Then we say that it is an trinomial, right? X plus y plus 2, or x square plus x plus 1, or x plus y plus z. Okay, so these are the trinomials because they have the three terms. And next type of algebraic expression is our topic, that is polynomial. Okay, so polynomials are an algebraic expression in which an algebraic expression having two or more than two terms, having non-negative integral exponents. Okay, two or more terms having non-negative integral exponents means they must have the positive powers. Okay, they must have the positive powers along with 0. Okay, So now we are going to discuss about a polynomial. Polynomial means an algebraic expression having two or more terms with non-negative integral exponents. Two or more terms having non-negative integral exponents. Okay. Non-negative integral means they must be positive, either 0 or they must be positive. They should not be negative. Okay. Remember the point. They should be in positive powers, not in any negative powers. It may be 0. Okay. Yeah. Then we say that it is a polynomial. Okay. An algebraic expression having two or more terms with non-negative integral exponents. Okay. And for your class, there is polynomial in one variable. Polynomial in one variable. Polynomial in one variable means a polynomial is defined in only one variable. Polynomial is defined in only one variable. Then we say that polynomial in one variable. Okay. If the polynomial is defined in only one variable, or the polynomial is expressed in only one variable, or the polynomial having only one variable, or the polynomial contain only one variable, is known as a polynomial in one variable. Let me have an examples. X plus x square plus 1 is a polynomial in one variable. The variable is your x only. Okay, you should not worry about the constant which is there with. Okay, we just see the variables in that polynomial. Okay, and it is also a polynomial in one variable. Okay, that is a variable here y. Okay, these are the polynomials in one variables, and the point you must have to remember, or the question may be asked, which of the following is a polynomial? If the algebraic expression satisfies the polynomial condition, that must be satisfies algebraic expression having terms with the non-negative exponents. Okay, non-negative exponents. So these are the variables having, all the terms having positive exponents. So these are the polynomials. Look at here. X root x plus x square plus 1 by x plus x square, 1 by x cube plus x square plus 1 by 2. So all of these are algebraic expressions, but they are not the polynomials. Why? Here, their integral exponent, that means x to the power. X to the power is 1 by 2. Root means it is 1 by 2. Okay, here x square there, but you should not consider this only the term of the polynomial. All the terms which are involved in the polynomial, they must have the non-negative integral exponents. Not only the single term, all the terms must have the non-negative integral exponents. Then only say that that is polynomial. Okay. Here it can be written as x to the power half. So it is not an integer. It is not a positive integer. It's a rational. Right. So this is not the polynomial. If the algebraic expression satisfies the non-negative integral exponents property, then we say that only those are polynomials. Okay. And next, here 1 by x plus x square. Here the x to the power 1 by x to the power 1. That means it is the reciprocal. That means it can, if we can write it as, it becomes x to the power minus 1. So its exponent becomes negative. So that's why it is also not the polynomial. And here 1 by x to the power 3 plus x square plus half. So it is an algebraic expression. Okay, but it is not the polynomial. It is not the polynomial because one of the term is having negative exponent. If, remember the point one only, that is, if the terms which are having rational exponents. Okay, if the terms having rational exponent, that means in the form of p by q, like this, they are not the polynomials. If the terms the variables are in the denominator, then they are also not the polynomials. Okay, have you got the idea? If the terms are in the denominator, and that means variables are in the denominator, then we say that those are not the polynomials. Then if their exponents are becomes negative, then they are also not the polynomials. If their exponents become rational, then we are also say that those are polynomials. Those are not the polynomials. Okay, have you understand? Okay, next. So next we are going to discuss about the degree of the polynomial. Degree of the polynomial means the highest power of the exponent, the highest power of the term in a given polynomial, the highest power of the term in a given polynomial. Here we are consider only the exponents of the variables, not the exponents of the constants. Okay, the degree of the polynomial is the highest power of the term in a polynomial is known as the degree of the polynomial. Let me see an examples how we have to say or how we have to find the degree of the polynomial. So these are the examples of polynomials, right? So these are the polynomials in one variable, because the variable is involved here x only. Here for this polynomial, the polynomial in which the highest power of the term, the highest power is 3, so its degree is 3. The degree of the first polynomial is 3, and next the degree, first you have to see the exponents, which is the highest exponents here, that is 5. So its degree is 5, and next here in this polynomial the highest power is 9 and its degree is 9 only. Okay, so the degree of the polynomial is 9. The degree of the polynomial is the highest power of the exponent, the highest power of the given polynomial. The degree of the polynomial is the highest exponent of the term in an polynomial is known as degree of the polynomial. Okay, so depending on the degree of the polynomial, we are going to classify the polynomials as several types. Depending on the degree of the polynomials, we are going to classify the polynomials into several types. Let me see one by one. Linear polynomial. Linear polynomial means the polynomial of degree 1. The polynomial of degree 1 is known as a linear polynomial. That is x plus 1 or y plus 2, 3y plus 1, like this. Here the exponent is 1, here also 1, here also 1. So that's why it is a linear polynomial. When we say that the polynomial is linear, if it has a, or the polynomial has a degree 1, okay, the polynomial has degree 1, then we say that a polynomial is a linear polynomial. And next, quadratic polynomial. Quadratic polynomial means a polynomial of degree 2. A polynomial of degree 2. We say that it is a quadratic polynomial. Examples: x square plus x plus 1, x square plus 1, x square plus x. So these are the examples for the quadratic polynomials in one variable. Okay, here the highest power is 2 only, so that's why the quadratic polynomial have degree 2. Linear polynomial have degree 1. Remember the points. Linear polynomial have degree 1. Quadratic polynomial have degree 2. And next, I want to discuss about cubic polynomial. Cubic polynomial. Cubic polynomial means the degree of the polynomial is 3. If the polynomial having degree 3, then we say that a cubic polynomial. Examples: x cube plus x square plus 1, x cube plus x cube plus x plus 1. So these are the examples for the cubic polynomial. Here the degree of the polynomial is 3 because highest power is 3 only. So here x cube is the cubic polynomial. X cube plus x is also a polynomial. X cube plus x plus 1 is also a polynomial. X cube plus x square plus 1, it is also a polynomial. So these are all the examples for the cubic polynomial in one variable. Okay, have you got the idea about the degree of the polynomial and the classifications of the polynomial in one variables? Okay, depending on the degree of the polynomials are classified into several types. In those several types, we have discussed 3 types. Okay, and the general forms of linear polynomial, quadratic polynomial, and cubic polynomials are as follows. Look here, linear polynomial. The general form of linear polynomial is ax plus b. Ax plus b is the general form of a linear polynomial. And quadratic polynomial, the general form is ax square plus bx plus c. Okay, here a, b should not be 0. Okay, and cubic polynomial. Cubic polynomial, the general form of cubic polynomial is ax cube plus bx square plus cx plus d, where a should not be 0. Okay, yeah, a only not should not be 0. If a is equal to 0, then it becomes a linear polynomial. Here, if a becomes 0, or if a becomes 0, and then it becomes a constant polynomial. Okay, a should not be 0 at anywhere. Okay, here if a becomes 0, then it becomes a quadratic polynomial. Here, if a becomes 0, then it becomes linear polynomial. So a must not be equal to 0, where a, b, c, and d are the real numbers. Okay. And next, if you have any doubts, please comment in the comment box. If you like the video, please like, share, and subscribe. Thank you.